So the first question that we're going to look at is taking a look at consecutive sums. So a set of consecutive numbers like 3 plus 4, 1 plus 2 plus 3, 5 plus 6 plus 7. So what I'd like you to do is play around with this. We can make a little list here. I've already done some of them, so let's make a list. Sorry, we don't need, well, I guess we can do one. We can try 4, 5, 6 is already over there, 7's already over there, so I'll skip to 8. So have a go at those, maybe we'll do the first 20. Have a go at those questions and we'll see what we can come up with for the consecutive sums. What I'd like you to think about is it possible to do this for all your numbers? Is there some numbers that can't? I want you to look at the pattern, see if you can make a conjecture about what you think that consecutive number sums can add up to. Sorry, it is still early in the morning. Why don't we try one before I let you go off on your own, in case those first 3 examples aren't clear. Somebody pick a number for me in that list I created, and I'll show you what the consecutive number sum could be.
8.
Sorry?
8.
8. Okay. Anybody think of like 1 plus 2 plus 3 plus 4 or something like that adds up to 8? 5 plus 6? Well, 1, 2, and 5 wouldn't be consecutive, so it would have to be 1, 2, and 3, or 3, 4, and 5. Okay, so that's what I mean by the consecutive number sums. I'm feeling a little lazy right now, so I'm actually going to pick 9, because I know that's just 4 plus 5. They have to be consecutive, okay? It's not always 2 numbers. You could do it with 3, you could do it with 4, as many numbers as you need, but they have to be consecutive. So hopefully that makes more sense, and I'll pause it here. You guys can, we'll work it out together. Okay, so it looks like people have some answers. Start giving them to me. Who wants to volunteer out some numbers?
1 plus 2 is 3.
1 plus 2, nice. Grab that one quick. Paul, what do you got? 3 plus 4 plus 5. Nice. Okay, what else do you have? Oh, I know I've seen way more than 2 numbers done out there. 5 is 2 plus 3, okay. 11 is 5 plus 6. 6 plus 7. 15 is? Nice one. Someone had their coffee this morning. 1 plus 2 plus 3 plus 4 plus 5, all the way up, that is 15. What else do we have? Ooh, someone else had their coffee there. 1 plus 2 plus 3 plus 4. Yes, Jappy. Oh, right, we've got that one. Sorry, I had to change it to 17. Anything else? Did anybody get 14? Sure, Paul. 2 plus 3 plus 4 plus 5. Yep, that looks good to me. 4 plus 5 plus 6. You're picking all the long ones. What else is there? Did anybody get 19? Yeah, 9 plus 10. Let's see here. Anything else? Okay, so I'll just... Sorry? 8 plus 9. Did anybody get 1, 2, 4, 8, or 16? Okay. Yeah, well, you know what? One is kind of a weird because it's only one number. You could do it with just 1. But anyways, we'll ignore that one for now. What else? And people are telling me 2 is impossible. What else? Do you think, is it possible to do 4? Pass. Well, 1 and 3, but they're not consecutive. 2 and 2, they're not consecutive. So no, it's not going to work for 4 either. Anybody seeing any kind of pattern here yet? Say it. It's hard to hear. Multiples is,
Like
yeah, you're on the right.
2, 4, 8, 16, then it would be 32. Like
Yeah, so you're on, you got the pattern, but those aren't actually multiples. Those are exponents, which is, you kind of said that there. But yeah, those are exponents of 2. So that's 2, 2 squared, 2 cubed, 2 to the 4th. So that's 1, 2, 4, 8, 16. If we kept going, we would find out that there are actually, the next number that won't work is 32, then 64, then 128, 256, and it would just keep going in that pattern. So that's the idea today, is we're going to look at these problems and we're going to make our conjecture about what we think the pattern is or the answer could be. So we're not going to spend much time. If you've ever thought, what do mathematicians do at university? They do the next step. They look at a problem, they make some conjectures, and they try to prove that they're correct. So math has the luxury of being the only deductive science, meaning it's the only one when you can prove something beyond any doubt. Like, you know how you might say this drug works in 95% of patients. In math, it either works in 100% or none. So that's what you would do if you wanted to go on and study math. You would make your conjecture and then prove it. But for us today, we're just going to be good conjecturers. You guys will all probably make enough money, you can just pay someone to prove your conjectures, right? You wouldn't have to do math anymore after high school. Here's a pattern for you. This, think about it as height. This is 1 triangle tall. This is 2 triangles tall. This is 3 triangles tall. So how many triangles would there be if we went to 5 triangles high, or 8 triangles high, or 10 triangles high? So see if you can work out something in the pattern or make a conjecture about this. Oh, and one thing, just to keep it simple for you guys, there's some of you, which would be excellent if you've done this already. You might be wondering, well, Mr. Joyce, do I need to collect these triangles as well? And the answer is no, we're going to keep it simple for today. We're just starting out this idea. So we're going to look at the small triangles only. Okay, so just count the small triangles. So does anybody think they're finding a pattern of some sort or want to share with us? Go for it. Paul then, yeah, I guess.
Starting from figure 2, like with the number of triangles that go up, like 1 and 2 right there.
Yep.
If you multiply them by 2, you get the number of triangles that are there right there.
So you're saying here there's 2 times 2, which is 4?
Yes. Counting the triangles that are upside down as well.
Yep. Yep. Okay. So there's 1, 4, and then does that still work when we get to a height of 3?
Yes.
So I'm not sure if I understand your pattern. You're telling me 2 times 3 is...
No, sorry, it's 3. The number of times.
Oh, squaring them.
Sorry.
Right, so then it would be 3 times 3, which is 9. Yeah, that works. There's 9 triangles there. So then for 5, what would you say?
5, it would be 5 times 5.
Right, so you'd say 25. So hands up, how many of you were able to find that pattern? Okay. How about for 8? What would you see in 8? How many triangles? Yeah. And for 10, we should find 100. Okay, so let's, time for a little game here. So this is the game of sim. What you're going to do is draw these, 6 dots on your page. People ask, can we draw more? Yeah, you can draw more. You can make another row on the bottom or underneath. That's fine. But this is the way the game is played. You and a partner ideally have different color ink. Say I'm going first. I'll connect dots like that. Then the next person might go and connect here. And then maybe I go there. And let's see, I don't know, maybe they do that. And then I go, haha, I win as soon as I make a triangle. Now, it doesn't have to be just one of the small triangles. The outside triangle counts as well. So any triangle of the same color, that person with that color wins. So try that for a few minutes. While you do, just a second, gang, while you do, the questions I'm going to have you think about is there an advantage to going first or second? And if you figure out a strategy, is it possible that there must always be a winner? Like, if you played optimally, can you guarantee yourself a win? Think about it that way. Okay. And so what do you think? Who wants to go first if they play this game? Nobody wants to go first? So who wants to go second then if they play this game? One person votes in the whole class. Let's try one more time. If you're going to play this game, would you rather be the first player? Hands up. Okay, so how about if you were second? Would you rather be the second player in this game? So what do you think? What do you think would be better and why? Do you want to make some kind of... So let's assume that we have competent people here, right? We're assuming that you're not playing a game where you just leave something out there and you make a total blunder. Well, does anybody want to tell me, what do you think of the strategy? How many people are consistently winning their game? How many people are consistently tying their game? All right. So what do you think? Would you rather be first or second? I heard another game out there people were throwing out. Oh, this is a lot like Connect the Dots, okay? Mitchell, what did you think it was like? It's kind of like tic-tac-toe. Did you notice if you were second, what was your job? To cancel out their triangles. Just like when tic-tac-toe, you're trying to cancel out their line, right? So all I'm trying to get at with you is maybe from your experience, you might be inclined to say it doesn't matter because if I'm second, I'll just make sure they don't win. And if I'm first, I'll play my best, but chances are the second person will just keep blocking me. So you might be inclined when you play this game to say it doesn't matter. As long as you play properly, there would be no advantage. Okay. Let's take a look at the product of two odd numbers. If you take two odd numbers and multiply them, will it always turn out to be odd? So here's my examples for you. 7 times 3 is 21. 21 is odd. 7 and 3 are odd. 3 and 5 are odd numbers. 3 times 5 is 15, and 15 is also an odd number. So you come up with a couple more. See, what do you think? Is it possible that you multiply 2 and get an even? All right, somebody give me two odd numbers.
7 and 5.
7 and 5, which is?
35.
Okay, so far still true. What else?
9 and 3.
9 and 3, which is? Still odd. Okay, anybody else? One more? 99 times 99? Okay, I'm going to need to pause here to get my calculator. One. So 9,801. Now, it is kind of funny that you picked 99, but 99 times 99, but that's really good because you really shouldn't believe all the simplest things you hear. You should say, I don't know, what about 1,000,000,005 times 7,965,841? Something like that, like two really ridiculous odd numbers. Because the more ridiculous your choices are, if those ones keep coming up odd, then you're going to convince yourself more and more, okay, maybe this is true. If all I gave you were the simplest examples and that was enough to convince you, yeah, you should. Good consumers are always trying to, question what you're doing. So be a good consumer and think of some complicated ways you could try to test these theories out. So for now, I think we're going to say yes for our group. We'll take a shot at explaining why that is in a minute, but let's just for now take a shot at saying it's yes. How about if we multiply two even numbers together? Would that always have to be even? Oh my, we're already shouting yes. How come? I played around with my calculator. Okay, well that's all you need to do for today, but people who didn't pick up a calculator, how come it's you're so sure that two even numbers makes an even number? Yeah, that's a good explanation. You have an even number of even numbers. So it really wouldn't, you only need an even number of some number. So that's enough to get an even number out of it. So yeah, I would agree. I think this is going to be true. Now, the thing about even numbers are numbers that are multiples of 2. So we could write two numbers. There's all even numbers. Every possible number, you give me a number for n, I'll tell you an even number. So if you told me, well, what's 5? N equals 5. That's 10. 6 would be 12. 7 would be 14. That tells me all even numbers. So what I could do is pick two even numbers. Two different ones. And because I'm multiplying by 4, that's 2 times 2, so I have a new even number. So that's another, I guess, more nerdy or geeky example. But you can use some algebra in there to prove that it would be true, because you've got an even number has to have a multiple of 2 in it. When I multiply them together, there's still a multiple of 2 in the answer. Okay, how about if we add things up? If we add up two odd numbers, what do you think happens here? Can you make a conjecture for me? What do you think, Shahid? Any ideas? Yes? Okay. Can anybody elaborate on yes for Shahid? Yes. Two odds always add up to an even. That's what it would appear like in our picture here. Give me a couple more odd numbers. Let's add them together.
5 and 5.
5 and 5, which is? Yes, and we're still odd. So, is anybody convinced just with 3 examples? 99 plus 99? Oh, never mind. Is that what you... So that'll be 200 minus 2, so 198. Okay. How about if we were to add 2 even numbers together? What do you think you get? You guys are even numbers are easy, right? You guys just seem to know the answers. So why is that?
Because you have an even number of even numbers.
Well, in this case, you're adding an even number to an even number. So you have 2 even numbers. So yeah, I guess that explanation still works. Okay, so yeah. So the sum is even, and here we said the sum is odd. Oh, sorry, even for both, sorry. Now, if I was to do this the geeky way, one way I could do that is, here's 2 even numbers. An even number has to have a multiple of 2 in it. If I add those together, that's the same thing as 2. So here's my new number with a multiple of 2 still in it. So that's another way you could do it. I'm not gonna walk you through this one for multiplication, but let's try it for odd numbers. If you think of the geeky way, like this, how would you describe an odd number? What do you think an odd number is? Like here's the list.
Just in case you forgot.
Yeah, just in case you forgot. Sorry, I don't mean to insult your intelligence here. But what do you think? What would be a way I could describe, what's a formula that gives me all the odd numbers? Sorry? Okay, so it would be 1 plus something 2. Is that right? Let's check it out and see if it's right. So that would give me like, if I put in 0, it would give me 1. If I put in 1, it would give me 3. Then 2 would give me 5. So yes, you are absolutely correct. So here's what happens when you add 2 odd numbers together. You go, here's one odd number, and you add the other odd number together. Then what you're going to end up with is 2 plus 2n plus 2k. Everybody has a 2, so I can factor it out. So there it is. Anytime you have a factor of 2, you have to be an even number. So this is an even number 2. So I don't mean to scare you guys. I just want to, give you some example of this is where mathematics goes once you make a conjecture. So today we're working on making those conjectures and coming up with our data to do it. This one here, it works the same way if you multiply like I did, but I'm not going to make you go through that pain. We've had enough here. How about this? This time we're going to, there's a couple questions I have for you. The first one is the difference of 2 perfect squares always odd? And here are my examples for you. Actually, first of all, hands up if you know what a perfect square is. I hope. Perfect square? Yeah, so here's some examples. 1 times 1 is 1, so yes, it is a perfect square. Yeah, 64. Can anybody give me another perfect square? Give me another one. 99 is not a perfect square. 100 is a perfect square. 81 is, yeah. So take a look at this list. If you subtract two of them, do you always get an odd number? Oh, you've already found a no. Okay, how? Okay, so 16 minus 4 is 12. So we have another even number here. Can we adjust this somehow? Because I'll tell you that in certain cases this is true. Do you want to take a look and think about what is it about the examples I gave you that makes it true?
1 even, 1 odd.
That's definitely part of this. 1 even and 1 odd. Yeah, that's actually smarter than what I was thinking. I was just thinking these are consecutive. Because here's the tie-in from what we were just talking about. 4 is 2 times 2. So this is an even number times an even number, which is?
Even.
Good. 9 is 3 times 3, which is an odd number times an odd number, which is? Odd. So it's going to go even, odd, even, odd, even, odd, all the way through even and odd. So if I pick any two consecutive numbers, then I know one's even and one's odd. So that means when I subtract them, I must get an odd. Okay, so anyways, but yeah, it would work if you just, like I think Mitchell was mentioning there, just pick 1 even and 1 odd. But this is the adjustment I would make, is 2 consecutive perfect squares.